Okay, let's start with the persistence layer. First, let me add the required dependencies on the pm.xml file. For that, let me go back to the Spring initializer and add these dependencies. So first dependency I need is the JPA data, and I need a driver also. Since I'm using Postgres, I'm going to use the PostgreSQL driver. And click on explore, just copy the oh wait, I'm taking Gradle, let me take the Maven. Okay, now we have the dependencies. I can copy it from here and let's paste it on the pom.xml file, and let's rerun the Maven. Okay, now the dependencies has been added, and let me add the URL and username and all those details to the application.properties. I will just copy it from the, it's not bad. So this will be the URL. I have already created the database called Robots Dev Monitor DB. If you have not created, you can create a database and just mention the database here in the URL. And same way you can provide the username and password. And please note that I have kept the DDL auto as none for now, because I don't want JPA to create the tables. For that, I will use a migration tool called Liquidbase. I will show you shortly. Next, let's create our entity class in entity package. Okay, I can copy the properties from the ICMP model, and we can annotate it with at entity. Then we also need the table name. I will name it as ICMP, and let's add the getters and setters as well. Okay, now it is given another. Okay, yeah. So when we annotate any class with that entity, it expects us to give an ID. So let me go ahead and create one ID and annotate it with at ID, and I want this ID to be auto populated by the database. So for that, I will use an annotation called generated value, and we'll keep the strategy as generation type dot identity. So this is our entity class. We also need one repository interface to interact with the database. Let me create one, and we'll put it in the repository package. Okay, let me extend this thing with JPA repository, and then we will provide the entity, which will be ICMP entity, and the data type of the ID, which is long, and we should also annotate it with at repository. So basically we are extending with JP repository, and it provides all the necessary CRUD operations that we can use. So it Spring Data automatically create the implementation for this. So that's it. We have our repository class now, repository interface now. Let's autoware our repository interface in the service class. Let's use the annotation autoware and then private ICMP repository. Okay, now let's save the entity. Now before that, I need to convert the model class into an entity class. For that, I will create another function that can convert the model to entity, and also I will keep one more function to convert entity to model. So let me go ahead and create those functions. Now we have our converters, so let's call it from the service class. So I can directly use the save method and just convert it using converter dot convert model to entity, and I can pass the model. I saw one mistake. I think I haven't renamed the function to entity to model. Okay, now let's try running this application. Okay, the application has started and scheduled job is also executed. Okay, now but we got an error saying relation ICMP does not exist. So it is obvious because we have kept the DDL auto as none, so that is why it is not created while starting up. So let me show you how we can do that using a migration tool called Liquidbase, how we can create a table for this ICMP entity. Okay, let's add the dependency first. For that, let me go back to the Spring initializer and add the Liquidbase. Go to explore and you will find the dependency here. Copy it and then paste it in your pom.xml file. Okay, now let's go back to the Liquidbase site and see what it is actually. So it is a migration tool, and this is how we can provide the scripts. So you will have a changelog file, and inside the changelog file you will define some change sets. So this change sets can be to create a table or modify a table. Like you can do a lot of things using the Liquidbase. Okay, and this can be written in multiple languages. For example, you can use SQL, XML, YAML or JSON formats. I personally like the XML format because it is easy to understand and it's very specific. Like you can give the change set, you can give the precondition. So I will choose XML for this video. So let's create our the changelog file first. Let's go back to the application, and then in the resource folder you can create a new package or directory called db, and you can create your first file, changelog.xml. And I have already created one XML for this, so let me copy it from the notepad and I will explain one by one. So this is a changelog and this is an XML language. So here is the change set. Okay, it has an ID and an author. So this helps Liquidbase to identify to keep track of the changes that has been already executed, or so it will just keep a track of it using this ID and the author and also the file name. And you can provide the preconditions as well. You can check if the table exists or not, then you can create the table. And it's pretty straightforward to create the table. You can use the tag called create table, and for creating columns you can use the colon. And there are some properties, just go through the documentation and you will understand. So this is the changelog, and next thing is we also need to provide one property for this, which will be spring.liquidbase.changelog. Then you can provide the path name, the URL. So it will be class path because it is inside the resource folder, and inside the db, and give the file name changelog.xml. Okay, let's run the application now. I hope it works. Okay, the scheduled task has executed. Okay, Okay, it doesn't give any error this time. Let me check the database first. Let me connect to the database. Database is Gobart's MonterDB. Okay, now the ICMP table has been created. Let me just show you the entries. Okay, these are now being added. And if you see, there are two more tables here, database changelog and database changelog. Let me show you these as well. So these are auto created by the Liquibase. It keeps track of the file that has been executed. Like I said, it uses the ID, the author, and the file name to identify the file. And there is an execution type also, it has been executed. So next time when you run this application, it checks if the data is available in this table, and if it is available, it will not execute this particular change set. So this is about the Liquibase. I hope you understood, and if you have any doubt, let me know in the comments. I will try to help. Now it has started recording the ping information to the database. Now let's create an endpoint to get this information from the database. So for that, let me go ahead and create one controller class in the controller package. Okay, so this is going to be a REST controller, and let me create one endpoint. I will use post mapping because I want to send a request payload also. So let's name this API as API v1 ICMP by timestamp. So this will be returning a response entity get and I also need one a payload class. So let me keep the annotation request body and create one a search request class. I will keep it in the model package. This will have a private instant variable from and we also need one string which can take a provider name. Let me import the classes. Now we have the search request. Now let's import this class as well. Okay, we also need to auto-wire the services. We'll do it by using the auto-wired annotation ICMP service. As it is returning a response entity, let me just return an OK response entity, and we'll call the service class from here. So it's ICMP service dot get ICMP models by timestamp and provider. Okay, there is no function as of now. Let me go ahead and create one. And this is going to give me a list of ICMP models. Okay, let me override this method, and this way we're going to call the ICMP repository interface and then get the details. So, but I want the details, I mean the ICMP models filtered by the timestamp and the provider. By default, JPA repository does not provide a function like that, but we can declare a function which JPA will be automatically giving us an implementation of it, and we can do that in two ways. One way is to just write a function and just give the annotation at query, and then you can pass your SQL query. The second way is you can tell the JPA in certain way, like you can use a naming convention in the function name itself, and then the JPA will be deriving a query for you from the name. So let me create a function called which will be giving me a list of entity, and the function name I will keep it as find by timestamp between and provider. So if you keep it like this, find by timestamp between and provider, this will create a query that will be filtering ICMP models by timestamp and the provider. And I also wanted to sort it by the timestamp. It should be in ascending order by timestamp. So for that we can use order by timestamp ASC for async. Now we need to pass the dates, which will be instant from and instant to, and we also need to provide the provider. So these are the only three things we need, because expect us to provide a timestamp and the provider, and then it will be ordering it by timestamp in the ascending order. So this is it. Let me call this function from the ICMP service, and provide the from timestamp. Oh wait, I think I haven't added the getters and setters. Okay, request dot get from, request dot get to, and request dot get provider, and this is going to get me a list of ICMP entity models, but I want ICMP models. So what I can do is I can just do a string, and then I can map it to I can create this entity into a model, and this is going to give me a stream. Now I can turn it into a list. So that's it. Now I want to test the endpoint. Let's see if we can get the information from the table. Okay, I have started the application now. Let's go to Postman. I have this request and payload ready. Let me hit the request now. I'm querying it from 2050 to 2055. There is a 5-minute gap in between, and I'm getting the response. As you can see, first record is at 2050 and the last record is at 2055. So it is filtering by the timestamp, and it is also sorting it by the timestamp. So that means this particular function that we have created, it works just fine, and we haven't provided any kind of query or anything. It just derive a query from this method name, and that is done by Spring Data JPA. So that's it. The application is ready now, and in the next video I will show you how to capture the logs into a log file, and then I will show you how to make a jar using the maven command, and also how to override the application.properties file using an external property file. So thank you once again. Thank you for watching this video.